Programming a microcontroller involves several steps, including selecting a microcontroller and development board. Choose a microcontroller that meets your requirements in terms of processing power, memory, and peripheral interfaces. A development board provides a convenient platform for programming and testing the microcontroller. Setting up the development environment. This includes installing the necessary software and drivers for your development board, as well as any libraries and tools required for your specific project. Writing the code. This involves creating a program in a high-level programming language, such as C or C++, which will run on the microcontroller. The code should take into account the microcontroller's architecture, clock speed, and available memory. Compiling and uploading the code must be compiled into machine code that the microcontroller can understand. Then, the compiled code is uploaded to the microcontroller using a suitable programming tool, such as a USB cable and an integrated development environment, IDE. Debugging and testing. Once the code is uploaded, you should test and debug the program to ensure it functions as intended. This may involve using tools such as oscilloscopes, logic analyzers, and debuggers. Integrating with other components. If your project involves connecting the microcontroller to other components, such as sensors or actuators, you will need to program the microcontroller to interact with these components. This may involve writing additional code or configuring the microcontroller's peripheral interfaces. Note that the specifics of programming a microcontroller can vary widely depending on the microcontroller's architecture, the development board, and the programming language used. There are several programming languages that can be used to program microcontrollers, including C. This is a popular language for microcontroller programming due to its efficiency and low-level control capabilities. It provides direct access to the microcontroller's hardware, making it well-suited for real-time applications. Assembly. Assembly is a low-level programming language that provides direct control over the microcontroller's hardware. It is highly efficient, but requires a good understanding of the microcontroller's architecture and can be difficult to write and maintain. C++. This is an extension of the C language and is also used for microcontroller programming. It provides object-oriented programming features and can make the code more maintainable and easier to read. Python. This is a high-level interpreted language that can be used to program microcontrollers, especially for rapid prototyping and testing. Basic. Basic is a simple, high-level programming language that can be used to program microcontrollers. It is often used for educational purposes and for simple projects where ease of use is a priority. The choice of programming language will depend on the specific requirements of your project, as well as your own personal preferences and expertise. In general, C and C++ are the most commonly used languages for microcontroller programming due to their efficiency and control capabilities. Sure, here are a few examples of microcontroller boards and the programming languages they commonly use. Arduino. The Arduino platform uses a combination of C and C++ for programming. Arduino boards are commonly used for hobby projects and educational purposes due to their simplicity and ease of use. Raspberry Pi. The Raspberry Pi is a single-board computer that runs Linux and can be programmed in multiple languages, including Python, C, C++, and others. It is often used for a wide range of projects, from home automation to computer vision applications. PIC microcontrollers. PIC microcontrollers are commonly programmed in C and assembly. These microcontrollers are popular for industrial and commercial applications due to their low cost and flexibility. Atmel. The Atmel platform uses C and assembly for programming. AVR microcontrollers are commonly used in a wide range of applications, including robotics, home automation, and consumer electronics. Texas Instruments MSP430. The Texas Instruments MSP430 microcontroller platform is commonly programmed in C. These microcontrollers are widely used in low-power applications, such as wearable devices and sensors. Note that these are just a few examples, and there are many other microcontroller platforms and programming languages to choose from. The best choice will depend on the specific requirements of your project and your own expertise.